Welcome to the Gap Talk Show, bringing you the latest news from the advanced packaging industry.
If you really enjoy this show, make sure to subscribe on YouTube, sign up for our weekly newsletter coverage online at packaging.Net.
Great. So now let's get on with today's show. Hi, Jillian. Great to see you again.
Hi, good to see you.
I know. All right, so I'm going to start off with, as I usually do, with what I have found on the wires in recent days. And something that caught my eye was the increasing price of DRAM. South Korea's DRAM export prices have literally gone through the roof. They've surged by a factor of 12.5 times from their low 3 years and 7 months ago, with the price of per kilogram now 41.7 times that of silver, according to a report from Chosun Biz. The report also highlights DRAM's soaring value when compared to gold. Korean-made DRAM can now buy roughly 620 grams of gold. Gold has also rallied sharply, but far less than DRAM, the report adds. So that's one big thing that I saw this week. The other quick shout out I want to do is to Zeiss company in Germany and say congratulations. They moved into their new 25,000 square meter factory space in Oberkochen, and that vastly increases their manufacturing capacity. So moving on to the main stories of the week. The materials provider Qnity Electronics just announced a scalable platform combining metallization, microbumping, dielectrics, and fine line patterning. The whole goal here is to help chip makers solve yield and integration headaches as AI forces shift from 2D design to complex 3D stacking.
Yep. And as we all know, advanced packaging technologies like CoWoS, EMIB, and others, they live or die by micro-scale precision. So if your coplanarity or your plating heights are off by even just the tiniest bit, the whole package can fail. So Qnity is positioning itself as a system-level design partner rather than just selling standalone chemicals with this piece of news.
Right. I mean, their portfolio covers a pretty wide range, everything from copper for uniform plating to solder for HBM microbumps and dry film photoresist for thick copper pillars. They're even addressing glass core substrates with their dielectric for through glass via filling.
Yeah, and I think that's really the main story here. Having access to compatible materials from one vendor, just one vendor, makes the process integration much easier for foundries and OSATs. And with that in mind, Qnity will be presenting the full platform at the Heterogeneous Integration Global Summit during SEMICON Taiwan. So we'll definitely need to keep our eyes out for updates there.
Yeah. Moving on to the next story. While all of these new innovations and facilities in the industry have been wonderful, they all fall flat if the world doesn't get its workforce shortage figured out. To help with that, Micron has just announced a new state-of-the-art training facility in Boise, Idaho.
So the facility is basically a mock-fab environment with real semiconductor process tools from big vendors like Applied Materials, Lam Research, and Tokyo Electron. And the reason for this facility, like you touched on, is to accelerate the onboarding for new hires, also give local students hands-on experience on actual production machinery.
Right, because capital and equipment are only half the battle when bringing mega fabs online. Micron has pledged over $250 billion in US manufacturing investments, and they're expecting to drive tens of thousands of jobs. Without a trained technical workforce ready to go on day one, expensive fab expansions risk sitting idle or suffering yield hits during ramp-up.
Yeah, and another big thing about this facility in particular is that it establishes a blueprint for U.S. semiconductor workforce development. So by putting industry standard tools and higher education coursework and public funding kind of under one umbrella, Micron is kind of solving basically a chicken and an egg problem where students now have access to proper training And this is because sometimes universities can't always afford these multi-million-dollar fab tools. And kind of along the same lines, I think this also can be replicated across the US and other parts of the world. And for example, I know that here in Arizona, TSMC and ASU are doing something similar. And I think that this framework for workforce development will become even more popular over the next few years.
Yes, yes. So let's talk about the shift towards integrated photonics now. The Fraunhofer Institute for Photonic Microsystems, or IPMS, just hosted an industry partner day where they showcased major developments in integrated optical components directly with silicon electronics onto a single chip.
Yeah, and this comes up kind of a lot, but the industry is quickly hitting a wall with traditional copper. And as AI and high performance computing continue to scale up, moving data electrically does generate way too much heat. And on top of that, it also limits bandwidth. So photonics is a prevailing solution to solve that data transport, but historically, optical components were too bulky and expensive to manufacture at scale. So this is a significant breakthrough here.
Right, and that's the real breakthrough from Fraunhofer. They've developed electro-optical devices built on a silicon nitride waveguide platform that runs on a standard 200mm and 300mm wafer lines. Because it's fully CMOS-compatible, chip makers can mass produce these photonic integrated circuits using existing silicon foundry infrastructure without having to retool entire fabs.
Yep, and they showcase tiny controllable chip mirrors that use light to help run quantum computers and print microchips without using physical stencils. They also built clear miniature screens directly onto standard. So basically, from they're laying the foundation for how we'll build faster computers, better sensors, and everyday displays for the decades to come.
Right, okay. Now, Nordson Electronic Solutions just launched their new ASYMTEK Vantage XL fluid dispensing platform, specifically built to handle panel-level packaging. As AI and high-performance computing pushes chips onto panels rather than standard round wafers, managing substrate warpage, thermal uniformity, and precision underfill dispensing has become a huge manufacturing hurdle.
Yep, and we'll actually be covering these tools and the growing role of panel-level packaging in the upcoming SEMICON Europa issue of GAP, so keep your eyes out for that.
Okay. So touching on wafers now, PR Hoffman just introduced a new diamond-like coated carrier designed for double-sided semiconductor wafer polishing. Wafer carriers are subjected to intense mechanical friction and corrosive chemical slurries, which usually causes them to wear down quickly, warp, or contaminate fragile silicon and compound substrates, like silicon carbide, during their planarization process.
Yeah, adding that diamond-like coating can make the carrier far tougher, more resistant to scratches, more resistant to harsh chemicals, and also resistant to friction as well. So the tool can last much longer without damaging the edges of the wafer. And for chip factories, this means lower equipment costs and flatter, more consistently thin wafers, which, as we know, is critical when you're stacking chips on top of one another.
Yeah, of course. Yeah. So that's it for this week. If you like this podcast, please like and subscribe on YouTube. And remember to share this with your friends in the industry.
Of course, you can also watch or listen to this episode and our future podcasts on YouTube, LinkedIn, Meta, X, and all your normal podcast locations like Apple and Spotify.
Okay. And that's it until next week. Goodbye from me.
Bye.